Okay, in this part of the lecture, we want to look at the biochemical reactions that take place in an ecosystem. So again, go back and watch that video on nutrient cycles in the weekly module, and that will give you a little bit more information and animate this for you. Now, in the biochemical cycle, we have nutrients, and that's the chemicals that are essential for life. And within living matter, the most abundant elements tend to be hydrogen, oxygen, and carbon, and that between those three, that's about 99% of the Earth's biomass. Now, what happens is we move through these cycles. These key chemicals move through these cycles, and that's what we call the biogeochemical cycles. Oxygen and carbon cycles are two of these, and they are related to photosynthesis and respiration. Photosynthesis is the main source of atmospheric oxygen. It breathes in the CO2, extracts carbon, and breathes back the oxygen back into the atmosphere. Now, the atmosphere links what we call carbon-fixing photosynthesis with carbon-releasing respiration. Okay, so this is kind of what that looks like. So here's photosynthesis, the sun, insolation. Hits the plants or the trees, so you get photosynthesis, releases organic carbon, decay organisms, releases oxygen back to the atmosphere, and plants will, of course, drink water from the ground, and they respire, they breathe back and release the oxygen back into the atmosphere, and you get carbon dioxide reservoir in the atmosphere. So what you want to try to do is intake this, absorb it, and release only oxygen. And you mess this up by adding more emissions into the atmosphere, adding more CO2 to the point where the trees aren't, or the living matter isn't, can't absorb it all. And so we end up with more CO2 in the atmosphere. Now, the nitrogen cycle, that makes up about almost 80% of the atmosphere. And the component of organic molecules is why it's so important, because of it's involved with proteins. And there's certain bacteria that take nitrogen from the atmosphere and make it available to organisms, especially clover and peanuts. So here's your nitrogen reservoir. Plants absorb the nitrogen and incorporate that into organic material, and it's released back into the soil. Plants decay and get to the soil. That helps keep the soil in equilibrium. But again, humans, by changing the atmosphere, you can upset all this. And that's why it's so important to minimize human-induced pollution, so you can keep the whole side of these nitrogen and carbon cycles and oxygen cycles in equilibrium. Now, nitrogen cycles are important because they add fertilizer to the soil. And humans use more nitrogen to synthetic fertilizer than all nitrogen natural sources. So, this is natural. We're fixing nitrogen into the soil, and we know nitrogen is good because it promotes the growth of plants. Humans add more to make plants grow faster, and then that gets into our waterways and play havoc with wildlife in there. And notice here, this is from your book, Figure 13.7, but notice the agricultural runoff, especially from here in what we would regionally call the Midwest. A lot of fertilizer gets into the Mississippi River, which flows into the Gulf of Mexico, and you can see how that affects the dead. You get this dead zone because the nitrogen, the other chemicals are replacing oxygen. Okay, now I'm going to stop here, and we're going to separate soil out from this because it's kind of its own topic, its own chapter. Now, there's soil videos in the weekly module, so make sure and go back and watch those, and they will explain what soil horizons are, and they'll give you some on-ground examples of how all that works.